Hello everyone, I'm Kapil Bhardwaj, Geography and Environment Faculty with StudyIQ. Welcomes all of you to the channel of StudyIQ. Today I'm here to announce something very good news for you. और उससे पहले मैं थोड़ा सा एक अपना एक्सपीरियंस भी शेयर करना चाहूँगा. When I was a student and was preparing for Civil Services Examination like you guys are doing, तो मेरी सबसे बड़ी जो प्रॉब्लम थी वो प्रॉब्लम ये थी कि different type of resources are required to be collected. Let's say मुझे एक टॉपिक पढ़ना है तो sometime it was NCERT, sometime A reference book, sometime B reference book and so on and so on. अब उसी से क्या होगा, उसी से मुझे नोट्स भी बनाने पड़ेंगे. That will be more time investment. तो I think जो आपका एक पॉइंट आता है टाइम मैनेजमेंट का, वो बहुत ही वर्स्टली मैनेज हो पा रहा था. बट नाउ आई एम वेरी हैप्पी for you people because you have something very good for you regarding time management, regarding not referring the multiple resources, and that good thing is the book, the physical geography book launched by the StudyIQ. This single book I will recommend to all of you guys for completing your geography portion, right? Very soon, you will be also having a similar book for the Indian geography. Combining both these books, in total, I will say, will serve everything related to geography for your examination. अब इस बुक के अंदर इतने कॉम्प्रिहेंसिव वे से आपके डायग्राम्स बनाए हुए हैं, इतनी सिंपल लैंग्वेज के अंदर आपके कॉन्सेप्ट को एक्सप्लेन किया हुआ है, that I am becoming fan of this book. And basically, जो आपका डिजिटलाइजेशन का सिस्टम था, जिसमें हम डायग्राम्स को देखते थे, वो सारी चीजें, वो सारे ग्राफिक्स को बड़े अच्छे से यूज किया है. एंड लास्टली बट नॉट लिस्ट, मोस्ट ऑफ द पीपल इग्नोर ह्यूमन ज्योग्राफी एज देयर पार्ट. बट यहां पे ह्यूमन ज्योग्राफी को भी, इकोनॉमिकल ज्योग्राफी को भी, मिनरल रिसोर्सेज के बारे में भी बात करूं, वट एवर द टॉपिक आई वुड लाइक टू टच अपॉन, वो बहुत ही कॉम्प्रिहेंसिव वे से इसको कवर किया गया है. That's why I will request all of you to purchase this book. As you guys are aware, it is available for the Flipkart and the Amazon as well. तो आपका description में जो भी link है, whoever want to purchase, you can purchase. But yes, I'm the fan of this book. I will recommend this. Even I am feeling somewhat jealous that कि मैं student था तब ऐसी book क्यों नहीं आई, ताकि एक जो burden था, जो energy थी, that is getting diverted unnecessarily towards collecting resources, वो सेव होती और वो आपके एफर्ट जो आपके एग्जाम में लगते हैं. अब इसके साथ में StudyIQ is giving you comprehensive discussion for this book as well. I will be taking all the topic of this particular book on our app, on our YouTube as well. On YouTube you will be getting some of the videos, and the rest of the complete chapters discussion will be there on the app free of cost. So that is basically an add-on gift will be available for you from the side of the StudyIQ. So whenever you will be facing any of the problem on this topic, you will easily be able to cover. So let's start. आज का जो topic मैं आपको पढ़ाने वाला हूं, that is about the atmosphere, chapter 8. I will be referring from this chapter. From this book, you will be opening your chapter 8. Chapter 8 is on the 91 page that I am going to teach you as of now. Chapter 8 is related to atmosphere. What the chapter 8 is? The chapter 8 is related to atmosphere. Okay, the first of all, the good thing is, what do you understand by atmosphere? So atmosphere is nothing. ये क्या है? एक blanket of gases है. Atmosphere क्या है आपका? एक blanket of gases है surrounding the earth. Blanket of gases surrounding the earth is named as atmosphere. How this blanket is basically present right there at the same position, it's not changing its position. It is because of the gravitational force of the earth. It is the gravitational force of the earth which basically maintains the atmosphere surrounding the earth. Now I want to extend myself toward the proper topic, and that is atmospheric pressure system. Atmospheric pressure, right? That is atmospheric pressure. Now you know the first topic which you have is the nature of atmospheric pressure present right there in the earth. So when it comes to the atmospheric pressure, what do you understand by atmospheric pressure? Nature तो बाद में आएगा. What do you understand by atmospheric pressure? Actually pressure, the word pressure means force implemented per unit area. This is known as pressure. So in the similar way, if I will be talking about the atmospheric pressure, the atmospheric pressure is nothing. When I will say this blanket of gas, which was atmosphere, it will also be exerting some force on the Earth's surface area, right or not? That's why that force per unit area will be named as pressure. Okay. Then how I will measure this pressure? I will be measuring with this pressure with the help of a unit which is named as bar. And I am also having an instrument for this, that is for measuring the pressure, and that is barometer. Barometer is the instrument that I will be using or I will be utilizing for measuring the pressure, and the unit of pressure is going to be bar, right? This is the basic thing which is required to be understood related to the atmospheric pressure. Now after that, very important topic that comes over here is what are the factors which can influence the pressure over a system? What are the factors which can influence the atmosphere? So when it comes to the factor, so I think everyone is aware that whenever we have the gases surrounding us, then obviously those gases are going to follow the scientific rule. And the scientific rule is the pressure is dependent on many more things. That is, I think everyone is aware about a gas equation which used to be PV equals to nRT. That is P pressure, V volume, N density, T temperature. These are some of the elements on which basically the pressure depends upon. So basically the pressure is dependent upon volume, it is dependent on density, it is dependent on temperature as well. Now the question is how pressure is basically dependent on temperature, dependent on volume, dependent on density. That we can look upon. When it comes to density, let's say, if a particle is more dense, then in that case, the pressure will be higher. Why pressure will be higher? Because you can simply understand, initially I had told you कि pressure क्या है? Pressure is the force exerted by the particle over an area. If the particle are denser, तो ज़्यादा force लगेगा. ज़्यादा force लगेगा तो force per unit area, force के तो directly proportional है pressure. तो फोर्स ज्यादा होगा तो प्रेशर भी ज्यादा होगा. तो whenever the particle are dense, more pressure will be exerted by them. Second thing is, the another important factor is temperature. Another important factor for pressure to be influenced by is temperature. अब टेम्परेचर का प्रेशर पे क्या इंपैक्ट होता है? देखो, जब भी अगर मैं आइडियली बात करता हूं तो टेम्परेचर का प्रेशर पे इंपैक्ट ये होता है कि हायर द टेम्परेचर, अगर मैं टेम्परेचर इंक्रीज करूंगा so you know the energy with the molecules will be high. If I am heating something, then obviously those molecules starts moving at different paths. So in the similar way, if I am increasing the temperature, then the molecule of the gases वो भी क्या करेंगे? Move on करना शुरू करेंगे, वो ज़्यादा force exert करेंगे. So with increase in temperature, there is high pressure. Means pressure also increase, but keeping all other things constant. Keeping all other things constant. Like if you will take, let's say, a jar in which you have a gas, right? The volume of jar is 20 liter, let's say. Now you start heating up this jar, obviously the gas particle will going to have an increased pressure. But unfortunately, if this jar blasted out and then the volume becomes infinite, then at that time I can't say with increase in temperature there will be increase in pressure, because now the other parameters like volume is not constant. So that thing even happen with the atmosphere as well. Because when in geography we want to study about atmospheric pressure, then in that case volume is not constant, right? Because if you will look at the atmosphere, the gases which are present into the atmosphere, do you think they are present in a jar? No. It has infinite volume. So now at that time what will be happening? So in case of atmosphere, if I will be increasing the temperature, obviously the heated particle becomes lighter and they start escaping from the place. And that's why lead to low pressure situation. It lead to low pressure situations. So in case of atmospheric geography, when it comes, then the temperature, high temperature is correlated with low pressure, but unfortunately it is happening because other conditions are not constant, like volume is not constant. So over here, volume was constant. That's why temperature was directly proportional with pressure. But at the atmospheric study, the high temperature is most of the time correlated with the low pressure. High temperature will be most of the time correlated with low pressure. So we had talked about density, we had talked about temperature. The third pillar, which is very important, is volume. Volume is inversely proportional to pressure. Larger the volume, lesser will be the pressure. So if the volume is high, pressure is going to be low. Volume is low, pressure is going to be high. Like you can take example, suppose I am having a cylinder of 20 liter and in which I am having certain gas, and if I will transfer this gas in a cylinder of 10 liter volume, then automatically what will happen? Pressure will be very high in this cylinder. Pressure will be very high in this cylinder. Simply I can say when it comes to the pressure and volume correlation, then yes, it is inversely proportional to each other. So these are some of the factors which are defined right here. Okay. Now there are certain even things of dynamism which are correlated with the pressure when it comes to the Earth's pressure. Earth pressure means the atmospheric pressure. These are the things which we are talking about a system. But when it comes to the atmospheric pressure, then I will say there are certain more things, that is dynamic factors, which are also involved for deciding a pressure will be high or not. Let's say, suppose you are having a glass of water and you are rotating this glass like this. Then you don't think so. After some time, the water will try to come out of the glass. Yes, you know. Yes, certainly the water will try to come out of the glass. In the similar way, when Earth is moving, then at that time you don't think so Earth will also be forcing the gases to escape out from there, right or not? To escape out from the same place, yes or no? Yes. That's why when it comes to the atmospheric pressure of the Earth, then I will say the atmospheric pressure of the Earth can be high pressure, it can be low pressure. Now there are two conditions. High pressure because of low temperature it can be. Low pressure because of high temperature it can be a low pressure. Because earlier I had told you high temperature on the atmospheric circulation is correlated with low pressure. But opposite to it, these both things I will say are thermally induced belts. But there are certain dynamic factors like revolution, rotation of Earth. At that time, there can be high pressure as well as low pressure. Like over here, if you will ask the example, then I will say the equatorial low pressure belt is a thermally induced belt. In the similar way, polar high pressure belt is a low temperature belt which is also a thermally induced belt. But when it comes to the high pressure because of dynamism, then it is subtropical high pressure belt. Subtropical high pressure belt is because of the rotational motion of the Earth, the wind which rises up from the equator, it descends over the subtropical high pressure belt. That's why it is a dynamic belt. In the similar way, the subpolar low pressure belt is also a dynamic belt. So there are certain dynamic factors like the Earth's rotation and revolution, they also affect the pressure over the Earth, which can lead to the development of high pressure or low pressure. Now, after discussing the basic things about the pressure, we reach to another topic which is mentioned right there in your book, is vertical distribution of pressure. So when it comes to the vertical distribution of the pressure, then you can imagine when we talked about the vertical distribution of the pressure, then what do we have? We simply can understand with increase in altitude, there will be decrease in pressure. Now the question is why? Question is why there is a decrease in pressure with increase in altitude. First of all, you must understand the example. What is the example which proves yes, there will be a decrease in pressure with the increase in altitude? You can imagine about the mountaineers, those people who used to climb up the mountains, they always have their oxygen cylinder with them. Why they used to have oxygen cylinder with them? It is simply because when they reach up to the high altitude, at that time the atmospheric pressure becomes less. That's why oxygen is not sufficiently available. ऑक्सीजन जो है उस टाइम पे वो सफिशिएंटली अवेलेबल नहीं है, दैट्स व्हाई वो क्या करते हैं, अपने गैस सिलेंडर साथ लेके जाते हैं। अब ऐसा क्या हुआ कि ऑक्सीजन इज नॉट प्रेजेंट राइट देयर? व्हाई ऑक्सीजन इज नॉट प्रेजेंट राइट देयर एट द सफिशिएंट प्रेशर? इट इज सिंपली बिकॉज अर्थ itself is a large mass. The large mass of earth itself have its gravitational force of attraction. Now the gravitational force of attraction basically attract the gases, heavier gases, towards the earth's surface. That's why the lighter gases will be available in the upper atmosphere, but the heavier gases will be available at the lower surface. Because of which, if I will increase the altitude, then lesser gases will be present, and automatically the atmospheric pressure at the vertical section is going to decrease. Okay, this is the vertical division. Then what about the horizontal temperature distribution? What about the horizontal pressure distribution? So is there any pattern for the horizontal temperature distribution as well? Yes, we do have a certain pattern which decide even the horizontal distribution of pressure. Now what is the pattern? Actually, when it comes to the horizontal distribution of pressure, then again there are multiple factors which basically works upon the horizontal distribution of pressure. Those multiple factors can be in such a way, like if you will see the Earth's shape, then Earth is in this shape. And you know the equatorial region. The equatorial region is the region which receives most of the sunlight. Most of the sunlight, most of the insolation is received by the equatorial region. So if you will implement the previous concept of the temperature and pressure correlation, then you will found, or you will easily be able to conclude that this particular region, which is 0 degree north, or I will say 5 degree north and 5 degree south, this particular region, because of high insolation received by them, the wind becomes warm in this region. That's why the warm wind always try to rise up, because the warm wind becomes lighter, and lighter material always try to rise up. This is known as convection wind. Now let's say this is a surface. This surface got heated up, and because of heating of this surface, the winds becomes warm and become lighter, and that's why it leave the particular surface. So what do you think? This high temperature surface will be having low pressure conditions or not? Obviously it will be having low pressure conditions. That's why the belt which is at the equatorial region used to be known as equatorial low pressure belt. The belt at the equatorial region will be named as equatorial low pressure belt. Now if you will imagine that the wind which is rising from here will lead to increase in its altitude, that's why after certain height, कुछ height travel करने के बाद, this wind becomes cool. The cool wind try to descend at some places, because cool wind becomes heavier, and heavier wind will always descend. So right here, from equatorial region, the wind starts rising up in both the direction. Why in both the direction? Why it is changing its direction? Because of the circular motion of the earth. At some place it will be descending. At some place it will be descending. Where it will be descending, it led to the development of subtropical high pressure belt on both the hemisphere. On both the hemisphere, it is leading to subtropical high pressure belt. The reason is quite simple. Over here, descending limbs of the winds are found, and descending limbs automatically used to be cool, and that's why they used to sink. So right here, what do we have? We have the subtropical high pressure belt on both the sides. Apart from it, if I will go to the polar region, let's say, first of all, I am going towards the polar region, then you know the polar region is the region which is going to receive lesser amount of insolation. So temperature over here is going to be very low, and very low temperature will automatically shrink something. wherever something will come in contact with the low temperature condition, then the thing is going to shrink. That's why we will be having high pressure belt. That is known as polar high pressure belt. This is known as polar high pressure belt. Polar high pressure belt. So on both the hemisphere, I will be having polar high pressure belt. Now you can understand, if it is a polar high pressure belt, this belt is a polar high pressure belt. And over here we have the subtropical high pressure belt. So at this point, below this nearly 66-degree altitude on both the hemisphere, in comparison to the polar high pressure belt, I will be having little low pressure. Right or not? Because comparative to 90-degree, over here we will be receiving certain sunlight. That's why this is known as, because this is subpolar region, subpolar low pressure belt. Subpolar low pressure belt. So from here, what I can say the equatorial low pressure belt and the polar high pressure belt. These both belts are thermally induced belt. It is because of the these belts are because of the temperature differences. Either the temperature is low, that's why the low pressure belt is getting, a high pressure belt is getting developed, or the temperature is high, that's why low pressure belt is getting developed. At equatorial part, more amount of insolation is received, so pressure कैसा हुआ आपका? Low pressure. At polar region, high pressure is there because of low temperature, because of low insolation. And these two belts, can't I say these are dynamically induced belt? Can't I say these are dynamically induced belt? Why dynamically induced belt? Because here there is no role of temperature is found. Over this point, what was there? Descending winds were found over there. Descending winds were found over there. So these both belts are dynamically induced. On this side, these both belts are dynamically induced. Over here, whether this belt or whether this combination, these are thermally induced belt. So simply I can say the polar high pressure belt and equatorial low pressure belt are thermally induced belt. But when it comes to the subtropical high pressure belt or the subpolar low pressure belt, these are dynamically induced belt. So from here, we can conclude that the pressure is dependent on thermal factors as well as it is dependent on the dynamical factors. Apart from this, there is one more important factor on which the pressure depends, and that is moisture. That factor is moisture. Moisture is also one of the factors on which the pressure depends. Now the question is, how can it be possible that the moisture is also acting as a deciding factor for pressure? See, very important thing is, moisture in any air, if is high, if in any air packet high moisture is there, then the pressure used to be low pressure. If low moisture content is there, pressure used to be high. Now you may be thinking that how can it be possible? So the simple example which is very much correlated with your life that you have to understand, that is, आप अपने रूम में एसी चलाते हैं, आपने अपने रूम में एसी चलाया, एसी चलाने के बाद क्या हुआ? Water. There is a drainage pipe in your AC. From there, water will be rejecting out. वो पानी कहाँ से आया? वो पानी आया आपके मॉइस्चर जो आपके स्पेस में अवेलेबल थी, उसको एसी ने एब्जॉर्ब किया, और दैट्स वाई आपका जो स्पेस है वो कूल डाउन हुआ. मतलब क्या हुआ? जब भी आपका सरफेस कूल होगा, उसकी मॉइस्चर होल्डिंग कैपेसिटी क्या होगी? कम होगी. कूल सरफेस, लेस मॉइस्चर. ये चीज आपने अपने विंटर टाइम पे भी फील की होगी. इन विंटर योर स्किन बिकम ड्राई. व्हाई? बिकॉज मॉइस्चर इज नॉट देयर इन एयर, तो आपकी स्किन से मॉइस्चर सक कर लेती है एयर. बट इन समर योर स्किन डजंट बिकम ड्राई, क्योंकि समर में टेम्परेचर ज्यादा है, ऑलरेडी आपकी विंड में मॉइस्चर है, इसलिए वो आपकी स्किन से मॉइस्चर को एब्जॉर्ब नहीं करती है. इसका मतलब क्या हुआ? हाई टेम्परेचर मीन्स हाई मॉइस्चर. So simply I can say the warmer the air packet, more the moisture holding capacity of the packet is. In opposite to it, Cooler the air packet, less will be the moisture holding capacity of the air packet. Now you can correlate, if higher is the temperature, then automatically the pressure will be low. Pressure will be low and moisture holding capacity will be high. So high moisture means low pressure conditions, low moisture means high pressure condition. Opposite to it, you can even say in the continental part, in winter time, what I can say? The surface used to be very cool. Cooler surface means low temperature, and even the moisture is also low. Low temperature means low moisture, that means high pressure. That's why low moisture correlated with high pressure situations, and high moisture is correlated with low pressure situations. So it is about the moisture holding capacity of an air packet which decides the pressure situations. So these are some of the parameters on which the pressure is dependent upon, and this is the way by which we can say there is a horizontal distribution as well as the vertical distribution of atmospheric pressure is. Right? So this is basically the topic which is found in the first part of your chapter 8 of this book at the page 92, that you can refer right there. Okay, so I will be coming with certain short videos of this kind with you. Even the complete chapter discussion I will be doing with you with the smaller fragmentation, so that your comprehensive study will be there with the help of the StudyIQ. So if you want to go for this book, then I will recommend, yes, you must go for this book, because this is the single resource which is required for completing your geography. Okay guys, thank you very much. We will be meeting very soon in the next session. Thanks a lot. Take care of yourself.